Bueno, es un verdadero placer darles la bienvenida hoy al lanzamiento oficial de Certillus Dairy. Es un proyecto que nace del compromiso y la pasión por ofrecer soluciones innovadoras, confiables y de la más alta calidad. Este lanzamiento representa mucho más que un nuevo producto. Es el resultado de un trabajo conjunto con personas que tenemos de invitados especiales, dedicación y esfuerzo de muchos equipos que creyeron en esta idea desde un inicio. Arm & Hammer y equipo gerencial de Vetim, don Arturo que está acá presente, cuya presencia hoy nos honra. Su acompañamiento, apoyo y confianza han sido fundamentales para hacer posible este momento. También agradecemos a cada uno de ustedes por estar acá, por su tiempo, por su entusiasmo, por ser parte de este nuevo capítulo. Con nuestros productos reforzados ahora con Certillus, damos un paso más en nuestra misión de seguir construyendo un portafolio sólido, respaldado y por ciencia, innovación y compromiso con nuestros clientes. Los invitamos a disfrutar de esta experiencia, conocer más de cerca este nuevo lanzamiento y compartir con nosotros la emoción de seguir creciendo juntos. Bienvenidos y muchas gracias. Vamos a dar inicio a la charla con el señor Vetim. Aquí está el señor Vetim. Él creció en una granja lechera en Wisconsin y siempre ha sido apasionado por las vacas lecheras. Tras completar sus licenciaturas y maestrías en nutrición lechera en la Universidad de Wisconsin, así como un MBA, Ben trabajó como técnico para una empresa de alimentos para animales durante varios años antes de incorporarse a Church & Dwight en el 2008. Actualmente ocupa el cargo de director comercial de la división de nutrición animal de Arm & Hammer en Norteamérica y Sudamérica.
Buenas tardes. And I'm very sorry, that will be the end of my Spanish. But I want you all to understand what I'm saying. So if I tried to fight through in Spanish, I don't think you would understand. So, thank you all for being here to join us. This is very exciting for us at Arm & Hammer to be launching this exciting new product and this new technology of our probiotics here in Costa Rica. So thank you for your time to join us. Also, thank you to Vetim, Dr. Iglesias, Carlos, the entire team here with Vetim. Thank you for our partnership. Thank you for letting us join you for this great event and share information about our partnership and about our Certillus probiotics. As Maria said, I grew up on a dairy farm. I live in Wisconsin. My family has a dairy farm in Wisconsin. I still help with that when I am able to. And we have Holsteins. We enjoyed touring a farm yesterday, and I learned a little more about the Costa Rican dairy industry. And so I know a lot of the, at least from the United States and in Wisconsin, a lot of the challenges and a lot of the problems that you face on dairy farms, as my family does that as well. So I would like to give you a little history about our company. So Church & Dwight Company is our parent company. Our business is Arm & Hammer Animal Nutrition. It's a very old company, been around almost 180 years. And Church & Dwight is primarily a consumer packaged goods company. So we sell a lot of different home care products, personal care products, things like that. And then sell them globally. We don't have a lot of those products in Costa Rica. I'll show some of those brands in a moment here. But we do have our animal nutrition business here in Costa Rica. And Church & Dwight was started many, many years ago, again, 180 years, by these two gentlemen. They were brother-in-laws, Dr. Church and Mr. John Dwight. And Church & Dwight started by selling baking soda. There are many, many uses for sodium bicarbonate or baking soda. Cleaning applications, deodorizing applications. As in dairy farms, we feed it to dairy cows as a rumen buffer. And so in 1956 is when Church & Dwight entered the animal nutrition business, selling sodium bicarbonate to dairy farms or to feed companies. Since then, Church & Dwight has grown our animal nutrition business, and we've grown through acquisitions. We've acquired some other companies, but we invest a lot in research and development of new products and new technologies that are focused on solving problems at the farms. So I'll talk more about those in just a moment here, but these are some of the companies that we've acquired over the years in our animal nutrition business. And Church & Dwight has had a very nice history of success. So Church & Dwight, for the first 150 years, Church & Dwight was simply baking soda. Manufactured baking soda and sold it to many different applications. Then, in the early 2000s, Church & Dwight started acquiring companies. And when Church & Dwight started acquiring companies and the stock price, and again, Church & Dwight is publicly traded on the New York Stock Exchange, the stock price of Church & Dwight really started to grow. So Church & Dwight has been a very good investment for people who have invested in the New York Stock Exchange and in Church & Dwight stock. And our animal nutrition business has grown as well. When we look at the entire company, the entire corporation of Church & Dwight, about 95% of it, so in the United States and outside of the United States, that's our consumer packaged goods. That's the cleaning products, the home care products, the personal care products. And then about 5% is the specialty products division. Church & Dwight in 2024 was just over $6 billion US dollars in revenue. And again, about 5% of that is our specialty products division, which our animal nutrition business is part of. So Church & Dwight, the corporation, has a very diversified portfolio. And again, I know many of these brands are not in Costa Rica, but we, again, have home care products, personal care products, and then our specialty products division is our animal nutrition business. All of these brands, Certillus, which we're launching here today, Celminax, BG Max, A-Max, BioChlor, Decap Plus, those are all dairy cattle feed ingredients that we partner with Vetim in distributing here in Costa Rica. So our entire portfolio, we have 3 different categories of our portfolio. So we have our dietary supplements, and our sodium bicarbonate and an SQ810 is similar to sodium bicarbonate. We don't sell those in Costa Rica. We only sell those in the United States and in Canada. But BioChlor and Decad, they're dietary supplements. BioChlor is an anionic product we feed to dry cows, pre-freshening. Decad Plus is a potassium carbonate that is fed during lactation. And then we have our prebiotics and our yeast products in our portfolio. Celminax, BG Max, used for mycotoxin mitigation, and A-Max, which is a yeast culture. And again, all used by our partners Vetim. And then today, we're here to talk mostly about Certillus, the launch of our targeted microbial solutions, or our targeted probiotics, where we can sample in the field. And some of you are familiar with this because we did some sampling at your farms. We can sample manure on the farms. We can understand what the biggest pathogenic challenges are at the farm. And then we can use our portfolio of probiotic strains to specifically inhibit those greatest challenges and pathogens. And Jesse Thompson, my colleague, will be talking more about that later. So when we view the dairy industry, and Church & Dwight, again, since 1956, Church & Dwight has been serving the dairy industry with feed ingredients. And the dairy industry is changing. And this is globally. This is in the United States. This is in Costa Rica. This is in every country in the dairy industry. And we have all of these challenges, all of these pressures that as dairy farmers you face. My family's dairy farm, these are some challenges that they face as well. Some of these challenges we can be in control of and fix. Some of these challenges we can't be in control of and fix. But when we develop our strategy for our business at Arm & Hammer Animal Nutrition, we look at a couple of these challenges specifically and identify what are things that we do well and challenges that we can address. And there are 2 of them in particular on here. We talk about what consumers' expectations, and for expectations from consumers, like the reduction of antibiotic usage. In many countries, that's a very real expectation from consumers. what in the United States, consumers understanding or wanting to know where their food is coming from. That's a very real consumer expectation. And so the reduction of antibiotic use is something we can address through disease and pathogen control with some natural solutions like prebiotics and probiotics. And so how those align to some of our strategic goals for Arm & Hammer, and we have several goals within our business, but two of them I would like to talk about. One of them is expansion outside of the United States. Our business has been in the United States for many, many years, but just recently, just in the last decade or so, have we started, the last 15 years, U.S. and Mexico and Canada, North America for many, many years, but we've started to expand outside of North America more recently. So one thing we've identified is that we need the right partners to do that. And that's why Costa Rica has become a very critical country to grow our business in, because we have such a great partner in Vetim to work with. A second one of those strategies, so one of the main strategies being international growth outside of North America, outside of Canada, U.S., Mexico. The second strategy being innovation. And that's one thing I think as a company that we really do well, and we invest a lot in trying to find, again, challenges to what those biggest problems are on dairy farms, quite often caused by pathogens and leading to disease on farm. And so as we continue to innovate and look for those new solutions to help dairy farmers, help veterinarians, help dairy nutritionists, that is a real focus for us in our business in the future. So lastly, why do we think why is our group at Arm & Hammer work so hard for innovation and looking for solutions? One of them is this brand. Our logo for Arm & Hammer really stands for quality, reliability. It is a standard for purity, for reliability, for performance in animal products. Secondly, we continue to invest in science. We know that any of the products that we want to produce or any technologies we're going to have that we want to take, that we want to ask farmers, ask nutritionists, ask veterinarians to look at, need to have sound science and needs to be repeatable performance and then sound research behind those products. Jesse, when he comes up, he's going to talk a bit about some of our lab capabilities. In Wisconsin, right near the city of Milwaukee, we have a lab where we do all of this analysis, where we take samples from animals and manure samples, from feed samples from all over the world, and we send into our lab in Milwaukee and Wisconsin to analyze. And again, that's the real story behind Certillus and our probiotics, and Jesse's going to talk some more about that. And then lastly, I mentioned one of our two strategies being a focus on international growth, a focus on growth outside of North America, and a commitment to Latin America specifically. The countries in Central America, the countries in South America, we are investing to grow in. We're adding people to our team. We're adding resources to our business to grow in these areas. And so you'll continue to see Arm & Hammer here partnered with Vetim to continue to bring solutions, find new products to solve problems on farms. So with that, I would love, if I don't want to take a lot of time, but if I can answer any questions about the company that anyone may have about Arm & Hammer Animal Nutrition or Church and Light.
Thank you very much. Bueno, a continuación vamos a tener a Carlos Alvarado Sánchez. Él es el gerente del área de animales productivos. Es graduado como ingeniero agrónomo de la Universidad Nacional de Costa Rica. Cuenta con una maestría en nutrición animal de rumiantes de la Universidad de Córdoba en Argentina. Y ha trabajado en empresas costarricenses como asesor en nutrición animal, tanto en Costa Rica como en Nicaragua y también en Panamá. Actualmente tiene 6 años de trabajar para Vetim y desempeña el cargo de gerente de especies productivas y nutrición animal para Centroamérica y el Caribe. Adelante, Carlos.
Bueno, muy buenas tardes a todos. De parte de Vetim, para nosotros es un placer que estén acá. Creo que a la mayoría los conozco y personalmente pues les agradecemos, tanto nosotros como el equipo, por haber sacado el ratito y estar acá pues compartiendo un evento para nosotros bastante importante y que creemos y esperamos que sea pues muy beneficioso y que aporte al futuro de la producción nacional, tal vez en el mediano o inclusive a largo plazo. De mi parte, me permito a tratar de hacer como una introducción, una línea de tiempo pequeña, no me va a tardar mucho tiempo para tratar de montarnos sobre el escenario de lo que viene, que sería al final la presentación de Jesse y del doctor Elías como preámbulo de eso. Entonces, para nosotros pues ha sido un camino importante de varios años ya y que hemos tratado de llevar la batuta, inclusive pues tratar de ser los más innovadores posibles a nivel de nuestra empresa y también pues obviamente tenemos una muy buena trayectoria con socios comerciales como Arnold Hammer que nos han brindado muy buena tecnología y nos han acompañado en este camino, inclusive pues mucha gran parte de lo que se ha desarrollado es en conjunto con ellos. Entonces para nosotros hoy es un hecho muy importante, muy histórico presentar Certillus. No vamos a hacer mucho hincapié sobre esto, vamos a dejar que al final Jesse nos explique de la forma más concisa y más apropiada posible, pero nosotros traemos una ideología de innovación, perdón. Traemos una ideología de innovación, creo que es algo que la empresa ha palpado mucho en todos los que ya tenemos algún tiempo de estar acá y pues conversamos poco, pero siempre que tengo la oportunidad de conversar con el doctor hablamos de innovación, hablamos de desarrollo, hablamos de cosas diferentes, nuevas, inclusive de cosas que no se han visto. Entonces, pues para irnos muy hacia atrás, desde 1978 hacia la fecha, hemos tratado de llevar esa talla mundial con laboratorios que tanto en nutrición como en salud animal están entre los primeros 5 del mundo. Entonces eso es una competencia propia nuestra de estar a la talla de esos laboratorios y también nosotros respaldar esa investigación que hay fuera del país y tropicalizarla hacia nosotros. Entonces esa innovación y ese respaldo técnico nosotros lo asumimos con mucha responsabilidad y con mucho compromiso. Y ya para posicionarnos sobre un escenario, no a muy largo plazo, el proyecto comenzó en 2019. En 2019, pues muchos de ustedes ya estaban en el conjunto con nosotros y decidimos pues tratar de innovar, de hacer algo diferente, de llevarlo hacia otro nivel, donde pudiéramos no solo que fuera palpable en las fincas, sino comenzar un proceso de diferenciación a nivel de campo. En ese momento, creo que pocos se acuerdan, pero algunos estuvieron en el camino. Comenzamos con Bodymax, en ese momento tenía esa presentación y teníamos un producto enfocado hacia corregir el balance energético negativo de las vacas, como Megalac, que pues lastimosamente en ese momento lo tuvimos poco tiempo y va a existir, y con un cultivo de pared elevadora. Me imagino que algunos se acuerdan que era el famoso Amega, pero algunos lo llegaron a utilizar y conforme pasó el tiempo y comenzamos a tener esos diferentes cambios, en el 2020 tuvimos que migrar y dejamos de tener a disposición gases de sobrepaso y pensamos en micotoxinas. Entonces en ese momento pues prácticamente el 100% de las fincas que manejamos en el país teníamos micotoxinas presentes y decidimos migrar hacia ese mercado con Sedmanax y con VGMax. Para el siguiente año tuvimos un reto muy importante que fue comenzar a complementarlos y a que esa innovación se fuera viendo diferente. Entonces el principal cambio fue visual, hicimos un empaque propio, diferente, que es ese saquito rosado que creo que está por acá, y desarrollamos una diferenciación importante. En el 2021 ya tenemos prácticamente 5 años de incorporar hidroximinerales a las fórmulas de minerales, entonces eso fue un gran cambio. Y un gran reto para nosotros fue tratar de complementar todas las etapas productivas de los animales. Entonces en ese año comenzamos a trabajar con biocloro, un mineral para vacas en periodo tardío pronto, para el periodo de transición. Y ahí fue donde comenzamos a tratar de complementar lo más posible la distribución y lo que teníamos para trabajar en campo. A nivel del 2022 tuvimos un gran reto y algo muy positivo para nosotros. Ese año el equipo de Mohamed nos presentó una propuesta de desarrollar un preinicio de terneras diferente, algo muy innovador, muy diferenciado y que venía de Torreón en México hacia las latitudes nuestras. Entonces comenzamos a trabajar y fue un gran reto cuando al principio hicimos el análisis y nos dimos cuenta que un saquito de 25 kilos costaba lo mismo que un quital de preinicio de terneras del país. Empezamos a tratar de ver cómo lo medíamos, cómo empezábamos a justificar esa diferenciación. Y pues por dicha hoy creo que ha sido muy exitoso y es un producto bastante referente de Vetim, que en todas las fincas que lo utilizan ha aportado un granito de arena, que para nosotros es lo importante, que las cosas lleguen a aportar y a funcionar. Para el 23 tuvimos el segundo gran reto. Teníamos un excelente desempeño en terneras de cuna con el preinicio, pero cuando las sacaban de la cuna se los caían rotundamente. Somos pues una empresa fabricante de premezclas y suplementos, no somos fabricantes de alimento. Entonces, en conjunto con Mohamed, en ese momento se nos ocurrió la idea de por qué no peletizar el núcleo del alimento, quitando los granos. Y bueno, Orlando, que fue el que llevó el proyecto de la peletización a cabo, lo logramos. Entonces, logramos adecuar un programa de potenciación del crecimiento de ternera acelerado sin necesidad de tener 4 o 5 etapas de alimento balanceado, sino un suplemento topic para cualquier momento de la producción que la gente lo utilice. El año pasado ya complementamos con una tecnología bastante robusta. Ya logramos incorporarse en toda la etapa productiva de los animales, desde a partir de la cuna hasta el periodo productivo de los animales. Entonces eso fue gracias a una diferencia en la proveeduría, un salmonax mucho más concentrado, que nos dio la facilidad de poder incorporarlo a la gran mayoría de fórmulas. Entonces eso fue un gran momento para los cactus. Luego esa misma diferencia de tamaño nos logró adecuar el espacio para poder tener un mineral para vacas de ordeño que tuviera tanto ciprestante y micotoxinas como cultivos y paredes de elevadores especializados en la misma dosificación, sin tenerlos que hacer una dosis muy grande, apenas 150 grados por vata al día. Y por último, una formulación con Selmanax y Bioflor para vacas prontas, que antes se nos hacía muy difícil porque eran solo 56 gramos por vata de separarse, y con este lo logramos bajar a 5 gramos. Entonces, en la misma dosis logramos acomodar todo el conjunto de ingredientes y poder hacerlo mucho más robusto. Este año logramos completar un periodo de prácticamente 2 años de desarrollo de hacia dónde estamos, hacia dónde nos posicionamos y hacia dónde queremos llegar. Nosotros, pues históricamente, a Dios gracias, Vetim ha sido muy fuerte en el tema de antibióticos y en el tema de antimicrobianos, pero sabemos que la presión mundial ahora inclusive hay una revista que identifica cada 3 meses cuánta presión tiene el mercado sobre productos de antibióticos a nivel mundial. Entonces está en constante revisión, en constante actualización, y decidimos no quedarnos atrás. Comenzamos por ganado. Es el equipo más robusto de Vetim, con lo que más tenemos a disposición para comenzar a trabajar. Igual pues tenemos a la gente de Arma Hammer ayudándonos. Entonces decidimos innovar y traer el primer simbiótico a nivel regional, una combinación de un prebiótico y un probiótico en la misma fórmula, y pues esperamos que nos dé un gran resultado. La intención de esto es pues hacerlo lo más cercano a la realidad nuestra posible. Creo que siempre ha sido un tema muy importante en todas las mesas que compartimos, la tropicalización, y lograr hacer algo que sea ajustado a nuestras condiciones. Entonces, sin hacer mucho preámbulo de lo que va a exponer Jesse, nuestra tarea a nivel nacional fue mostrar 23 fincas, lo cual suman 5.500 vacas de ordeño. Más o menos andamos de un promedio de un 16 a un 18% de tasas de reemplazos, prácticamente en la mayoría del país, 6 provincias, únicamente exceptuando Limón, y logrando muestrar la gran parte de la cordillera completa del país, desde Guayabo a Gasas hasta Turrialba. y sin desestimar la zona lechera de zona norte, San Carlos. Entonces, así fue como lo muestreamos. Se tomaron muestras de heces, de dieta, ya fuera pastoreo y grano o pocas fincas que tenían el relleno total mezclado, ganados doblados, y heces y agua. Así fue como se comenzó el proyecto, y luego esas muestras fueron procesadas en el laboratorio de la Universidad de Nacional por el equipo del doctor Elías, que es la siguiente presentación, y nosotros lo que hicimos fue tabular y zonificar en base a raza, modelo productivo y producción de leche. Entonces es algo bastante importante y que nos va a beneficiar mucho poder disponer de algo que estamos desarrollando en conjunto con ustedes, porque realmente si ustedes no hubieran abierto las puertas de las fincas para poder muestrear y para poder enviar este tipo de microorganismos inertes a Estados Unidos, no hubiéramos podido lograr tener algo preciso a la medida para nosotros, para nuestras condiciones. Por último, ¿hacia dónde vamos? Ya a partir de estos días, ya tenemos de formulación la inclusión de Certillus en prácticamente la totalidad de los minerales de vacas de ordeño y en los 2 bovicalf. Entonces, a partir de la próxima producción, ya vamos a estar con la incorporación, y probablemente a la gran mayoría de los que nos ayudaron vamos a estar pues tocándoles la puerta para que podamos hacer un desarrollo de datos y empezar a llevar esa estadística que también es importante. Yo no soy el más apropiado para hablar de eso, pero estos microorganismos siempre están lastimosamente en constante renovación y siempre nos van a estar causando problemas. Entonces vamos a tener que estar en constante medición para lograr tenerlos bien determinados, bien mapeados, y que no se nos salga de las manos la situación. Y estar en todo el ciclo productivo. Para el próximo año vamos a dejar un poco el tema de las vacas. Creo que con vacas hemos desarrollado muchísimo y nos ha ido de maravilla. Entonces vamos a tener 4 grandes focos. En su gran mayoría el estrés calórico nos está afectando a todas las especies y a todos por igual. Entonces estamos en desarrollo de algo que aporte para ese tipo de problemas y que sea multiespecie, que podamos trabajar en todas las especies, tanto aves, cerdos como ganadería. Y los otros, si son mucho más enfocados o monogástricos, E. coli, que todo tiene gran trascendencia, ¿verdad? Y genera mucho problema. Entonces vamos a trabajar en aves y cerdos sobre E. coli, y un desarrollo importante en la agricultura sobre los problemas que tenemos ahorita con enterococos, y un tema que queremos desarrollar, que es la calidad de huevo. Ya pronosticado y hecho para comenzar el año, vamos a lanzar de Nutrivet. Nutrivet va a ser una marca de entremezclas para el mercado nacional e internacional, donde el primer producto va a ser enfocado para estrés calórico. Va a ser una mezcla de carbonato de potasio con Selmanax. Y para el tema de enterococos ya llevamos muy avanzado para aves y cerdos. Un producto que va a ir enfocado hacia enterococos secorum y enterococos fecalis en agricultura y para cerdos. Entonces, pues hacia ahí vamos. Esperamos que nos vaya muy bien, y de parte nuestra en cuanto a lechería, agradecerles por siempre brindarles el espacio y poder trabajar en conjunto para siempre tener buenos resultados, y cuando no los tenemos, pues tratar de resolver. Y por parte nuestra, si no lo logramos, buscar quien nos ayude. Entonces, con eso yo finalizo y le doy el espacio a Elías para que sigamos la vida a tiempo y terminar por Jesse. Muchas gracias.
Vamos a proceder con el doctor Elías. El doctor Elías Barquero es profesor e investigador de la Escuela de Medicina Veterinaria de la Universidad Nacional de Costa Rica. Orgullosamente fui estudiante de ayer, donde coordina el laboratorio de bacteriología del programa de investigación en enfermedades tropicales. Es microbiólogo con doctorado en ciencias por la Universidad de Costa Rica y posee amplia experiencia en bacteriología veterinaria, inmunología de infecciones crónicas y resistencias antimicrobianas. Su línea de investigación se centra en la interacción entre bacterias patógenas y el sistema inmunitario, particularmente en Brucella, Clostridium difficile y Salmonella. Ha sido conferencista invitado en congresos internacionales de inmunología y brucellosis y es autor de múltiples publicaciones en revistas de alto impacto como Nature Communications, Frontiers in Immunology y Plus Pathogens. Además, participa activamente en redes de vigilancia de resistencia antimicrobiana y en la formación de profesionales en microbiología y medicina veterinaria en Costa Rica. Muchísimas gracias, Doc, por estar aquí. Y adelante, el escenario sur.
Muchísimas gracias. Perdón. Muchísimas gracias primero por la invitación. Con mucho gusto atendí la solicitud para explicarles lo que hicimos en el laboratorio. Como lo comentó María José, yo coordino el laboratorio de bacteriología de la Escuela de Medicina Veterinaria, y la Escuela de Medicina Veterinaria tiene un laboratorio, para los que no lo conocen, que vende servicios, y nosotros como laboratorio fuimos contratados para ofrecer un servicio, y lo que les voy a explicar en qué consistió el servicio que ofrecimos, que tiene que ver con el desarrollo del producto que se está presentando el día de hoy. Ok. Nosotros lo que se nos pidió fue realizar aislamientos de Escherichia coli y Clostridium a partir de muestras de heces que colectaron durante el muestreo que mencionó Carlos. Voy a ser muy breve, es un tema técnico que pretendo hacer de forma muy sencilla para que comprendan qué fue el trabajo que se hizo en el laboratorio. Nosotros recibimos heces, ¿verdad? De forma muy organizada, con un muestreo muy bien definido. Tomábamos una porción de estas heces y las preparábamos en una bolsa estéril para hacer una especie de dilución de estas heces. Estas heces se mezclaban con una solución que se llama agua peptolana, que es básicamente un diluyente, y lo que generábamos era, como decir, una mezcla de heces, una dilución de esas heces. ¿Por qué teníamos que hacer esta dilución? Porque parte de lo que teníamos que hacer es cuantificar cuántas bacterias de E. coli y de Clostridium estaban presentes en esta muestra. Muy bien, después de que preparamos esta solución, después de que hacemos esta dilución, hacíamos, ¿verdad?, unas diluciones de estas heces y posteriormente hacíamos el cultivo. Este cultivo, ¿verdad?, se hacía en diferentes medios específicamente diseñados para aislar los clostridios y las E. coli, que es lo que les interesaba a ellos tener. Para eso utilizábamos unos medios de cultivo especiales que permiten recuperar de forma específica estas dos bacterias. Después tenía un periodo de incubación para que las bacterias logren crecer en estos medios de cultivo. Y teníamos lo siguiente, esto para los que alguna vez han visto una placa de Petri, ¿verdad? Son como unos platitos de plástico que tienen una especie de gel en la superficie y las bacterias crecen en forma de puntitos. Entonces, conforme tenemos las diluciones más bajas, digamos, se forman un montón de puntitos que se pegan, y conforme se van haciendo las diluciones, obtenemos platos donde se pueden contar de forma muy precisa cuántas bacterias. Y con base en esto, nosotros podíamos estimar cuántas bacterias por gramo de heces teníamos para los clostridios y para las E. coli. Y en ese tipo de definir exactamente ese valor, el valor de bacterias por gramo para esas dos agentes. Para que se den una idea, es un plato de cultivo que tiene Clostridium, ¿verdad? Este es un plato donde tenemos la capacidad de contar cuántos clostridios, y como sabemos qué dilución se utilizó, podemos saber cuántas bacterias por gramo de Clostridium tenía esa muestra en particular. Una vez que las contamos, teníamos que hacer la elección de 5 colonias de Clostridium para preparar un cultivo de cada uno de estos elementos. Entonces escogíamos 5, ¿verdad?, que se veían bien aisladas, y las pasábamos a un cultivo en caldo. Un cultivo en caldo significa que yo agarro la bacteria, la pongo en un caldo, y lo que hago es que amplifico ese clon, ¿verdad? Cada uno de esos lo amplifico. En ese consiste el procedimiento. Nosotros tenemos que tener 5 clones por cada muestra remitida. Eso se incubaba por 24 horas para tener la bacteria. En el caso de las E. coli hacíamos lo mismo. Este es un plato que representa el medio de cultivo y la forma en que se ven las colonias de E. coli. En este caso las colonias de E. coli son de color azul. Entonces hacíamos lo mismo, escogíamos 5 colonias de cada una de las muestras, las pasábamos al caldo para tener una amplificación de cada uno de sus clones y digamos que teníamos casi trabajo terminado. Se incubaba por 24 horas y venía la parte donde preparamos el material que iba a ser enviado, digamos, a Vetim para que ellos pudieran hacer el envío de cada una de estas bacterias. A partir de estos platitos que tenían la bacteria ya crecida, ¿verdad? Individualmente las colocamos en unos tubos especiales que permiten la preservación del ADN y que al mismo tiempo inactiva la bacteria, para que a partir de estas muestras de ADN ellos pudieran hacer los análisis que requerían. Y finalmente, esa es la última diapositiva, preparamos un material de texto donde describíamos, describíamos la muestra, el número de repeticiones, cuál fue la ilusión en la que creció, cuál fue el resultado de bacterias por gramo y finalmente cuántas colonias elegimos de esa muestra. Entonces podíamos tener una trazabilidad muy detallada de que de cada muestra que recibimos, cuál fue, digamos, el procesamiento que se hizo, cuál fue la carga bacteriana para cada una de las dos bacterias y finalmente reportarle la carga bacteriana y la cantidad de colonias obtenidas para cada una de esas muestras de manera que ellos pudieran trazar de forma muy precisa el origen de la muestra y las bacterias que se obtuvieron a partir de esa muestra. Y eso es lo que tenía para contarles. Es una explicación breve, digamos, del trabajo que hicimos en el laboratorio para que ellos tuvieran los aislamientos y el material genético para hacer los análisis que me imagino que ya se va a explicar con más detalle. Si tienen alguna pregunta, con mucho gusto.
Gracias, doctor. Nada más como para comprender un poco más. La identificación de la carga bacteriana, el fin era para saber el grado de exposición que estaban los animales en la finca y la identificación de las colonias era posiblemente para luego que se haga la categorización y el estudio poder determinar la patogenicidad de las mismas o había algún fin diferente.
Le voy a responder la primera parte porque la segunda le corresponde a los análisis que yo no hice. Lo que nosotros hicimos fue precisamente cuantificar, porque fue una de las cosas que nos pidieron. Ellos querían saber cuál es la carga que había. Yo supongo que querían saber no solo las características de los aislamientos, sino en qué cantidad venía en cada muestra. Probablemente es importante saber no solo si tenían muy poquito o más o menos o mucho, y después saber qué características tenía la bacteria en particular. Pero el estudio que se hizo posterior no estuvo bajo mi responsabilidad.
Jesse Thompson es el gerente del producto de microbiológicos para Arm & Hammer Animal Nutrition. Es licenciado en bioquímica por la Universidad de Wisconsin-Milwaukee. Cuenta con más de 16 años de experiencia en el estudio de los desafíos microbianos y el desarrollo de soluciones microbianas para la industria ganadera. Anteriormente trabajó en Danisco Animal Nutrition, DuPont y Agro Biosciences, empresa que fue adquirida por Arm & Hammer en 2017. Antes de ocupar el cargo de gerente de producto, Jesse dirigió el equipo de investigación y desarrollo de productos para rumiantes en Arm & Hammer. Thank you very much, Jesse, for being here, and on the stage is yours.
Thank you. Thank you very much, and thank you for having me. Thank you for the invite. Thank you for the hospitality. It's a beautiful country that you guys have here. I know we've embarked on this project maybe a year and a half, 2 years ago, that we started the sample collection and trying to identify customized probiotics specific to Costa Rica. So I hope to share some of the overview with you. So just to start off, going to give you a little insight into Arm & Hammer's approach on how we go about customizing probiotics. Following that, I think this has been referenced a number of times, kind of dive into some of the data, what we found from the samples that were collected throughout Costa Rica, and how we customize a probiotic solution best fit for this country. And then following that, showing you how we use these customized solutions in different geographies, different customized formulations, and what outcomes you can expect by using these customized probiotics. So one of the things that differentiates Arm & Hammer, and Ben alluded to it already, is the lab. And at our lab, we have a very deep culture collection. So we're getting environmental samples on a regular basis from different agricultural systems, as well as different water samples, soil samples. We're looking for a very rich diversity of bacteria. And with that, we've built a probiotic culture collection of over 82,000 potentially probiotic organisms that we're routinely analyzing and understanding what potential do these bacteria have and how can we use them to support our customer pain points. So about half of this probiotic isolate database is spore formers. So this is like bacillus, so they're stable, so they're hardy. They can survive the pelleting process, and the other half are non-spore formers that we use for other applications. With these animal samples, we also have a tremendous pathogenic collections, over 500,000 pathogens within our culture collection, isolated from a variety of species. We have E. coli, coliforms, Clostridia, Salmonella, as well as other pathogens within the industry. We've been studying some mastitis bacteria. We're starting to dive deeper into the Enterococcus world, as Carlos referenced earlier. So by understanding these pathogens, both from a diversity geography standpoint, allows us to understand which strains are going to work best in which geographies. So how we like to think about it, we like to use this dog analogy. Is there any dog people in the room? Dog people? You got a few, a lot more cat people maybe? So dogs are all the same genus and species. And if we look at these four pictures of these four dogs that are the same genus and species, functionally, they can do different things. So if I were to ask you the question, which one of these dogs would you pick to win a race? Which dog would you pick? Right here, right? The Whippet Greyhound is going to be the fastest dog, right? They're all the same genus and species, but functionally, they can perform different tasks better. And that's how we think about a lot of our Bacillus subtilis within our culture collection. We routinely screen them, we analyze them. When we compare them side by side, they're doing different activities differently. So we try to understand which bacillus are going to perform the tasks that we're trying to accomplish most efficiently. So how do we do that? I told you we have over 80,000 strains. So how do we narrow it down to one or two commercial strains that we want to bring and customize for a specific region? I understand that this is a very busy slide, but I'll kind of walk you through it. So if we start at our 80,000 potentially probiotic strains, we can narrow that down based on what is grass, what is safe to feed to animals, what is the format that we want to provide the probiotic in. Do we want a spore former? Is this probiotic need to be pelleted? That can help us narrow down this list to our first functional screen. So we have the DNA for these 80,000 potentially probiotic strains. We will pick a gene with a known function. In this case, this example is focused around pathogen inhibition. So if we know that bacillus can produce a certain antimicrobial that's going to inhibit the growth of Clostridium or inhibit the growth of E. coli, we can screen our culture collection and identify which one of these bacteria have this gene that could produce this antimicrobial. So then we move to this level. Just because they have that gene doesn't mean they're going to actively be producing that protein that's going to inhibit that specific pathogen. So we do functional screening assays like this, like the isolates we did from Costa Rica, to determine which strains functionally inhibit a pathogen within our broth assays. Then we can rank them, the best performing strains to the worst performing strains. And like I said, with the dog example, not all strains perform the same. So these are all Bacillus subtilis. These were very effective, red is good. These were very ineffective, all Bacillus subtilis. So we have to make sure we're picking the right dog to do the job. So we pick our top performing strains. They move to whole genome sequencing, safety testing to make sure that they're good, they're going to be stable, they're going to do what we want them to do. And then we move to in vivo trials. We put them in the animals and make sure that they're doing in the animals what they're doing in the lab. So we've taken this approach with a number of different products on the dairy side. The focus for today is mainly around Certillus as a direct-fed probiotic to cows and calves. Also a number of different environmental applications. bacillus with different functions to target different outcomes. But today we'll be focused on the cow and calf. So to jump into the customization process, what we found from the samples that were collected. So when we think about this and we think about customizing probiotics for specific regions, we know that different regions have different feedstuffs, different housing, different management practices that can all contribute to different challenges, different pain points, different pathogenic diversity. So we like to use this term, microbial terroir. Is there any wine drinkers in the room? Anybody like wine? No? Not a lot of wine. Couple wine drinkers up front? Come on. Have you guys heard the term terroir associated with wine before? So they use the term terroir because where the grape is grown, all the environmental factors impact the flavor profile of that grape and then impact the flavor of that wine. So we use that same approach when we're analyzing and customizing probiotics for different agricultural operations, trying to understand how that local environment is affecting the challenges that we can customize the solution around. So as we already talked about, one of our primary focuses for customizing dairy solutions has been Clostridium. So Clostridium are known spore formers, much like bacillus, so they're stable, they don't die easily. They're native to the soil, so anytime you get some dirt contamination in some feed, you'll find some Clostridia. So they're highly prevalent on dairy farms. So from some survey work that we've done in the past, almost 99% of cow fecal samples have Clostridium, but it's not necessarily whether it's there or not. It's the level that it's at and the type of Clostridium that we identify within that sample. We also find it prevalent within feedstuffs. TMR, fermented feed, about 85% is a whole database number. And we'll look at how Costa Rica compares. So Clostridia levels have been observed between a wide range. So we'll sample a dairy farm and sometimes we'll find very low levels of Clostridium. Contributing dirt factors, contamination within feedstuff, different stress factors. Sometimes we'll go in and find very high levels of Clostridia, typically dairy farms that are experiencing challenges like inefficient feed processing, HBS death loss, those types of things. And from the previous survey work, we've identified 3 dominant species: Clostridium perfringens, a known toxin producer, and then 2 other species of Clostridium that are less well understood, and I'll go into a little bit more detail about them. So first off, Clostridium perfringens. So Clostridium perfringens has the ability to produce toxins as well as other enzymes that can negatively impact the host gut health. It's associated with disease and damage to gastrointestinal barrier at high levels. So I stole this from this Goossens et al. Manuscript. If you look at this first panel right here, you can see a normal microbial population and Clostridium perfringens. And some Clostridium perfringens is to be expected at normal levels. But when you see this increase, you can see that the higher levels of Clostridium perfringens are eating away this first line of defense, this mucus layer, that then exposes this animal to toxins and is diverting energy to that animal's immune system to fight that pathogenic challenge. At this point, there might not be any clinical signs, any dead cows, but it's diverting animals' energy away from what we want that cow to do, produce milk, right? And then when you get into the third and fourth panels, you're seeing complete disruption of the epithelial cell leaky gut associated with death loss. And then that second group, Clostridium baryonchii, Clostridium bifermentans, are commonly detected in feed, and they're known to produce solvents. And these solvents are thought to negatively impact rumen function. And I'll go into a little bit more detail with some of our trial work that we did on that. And we've actually done some work. We've published a poster that's shown that these organisms can actually grow in the feed. Just sitting in a TMR, they can grow in aerobic conditions. So with that, we'll jump into the survey results. So from the 6 regions sampled, We sampled 23 dairies, and we had total 184 samples from July 2024 to earlier this year, January 27th, 2025, as the last samples were collected. Fecal samples were collected from cow and calves, as well as feed samples to identify Clostridia levels within the feedstuffs. And you'll see throughout this analysis, we analyzed the data by region. And this was important because if we see differences in different populations in different regions throughout Costa Rica, we may have had to customize specific pockets, new strains for different challenges. And this is the approach that we've taken in the US. So we wanted to analyze this to determine if these challenges were different. So samples were collected, and the professor did a very good job explaining the fecal processing of enumeration. After those isolates were grown, they were sent to the lab in Wisconsin, where they're analyzed on a molecular level. So we extracted the DNA, and we asked a couple questions. The first question we asked is, what species are present within that sample? So from those 5 dominant isolates within that sample, were they Clostridium perfringens? Were they some of the solvent-producing Clostridium? Were they potentially other toxigenic Clostridium that were identified? So we wanted to identify the species. And then, as a dominant population, Clostridium perfringens, as we've identified in all regions globally, we can ask another question. What's the diversity of the Clostridium perfringens in different regions and as a country as a whole? So these are the Clostridia count results. So this is a logarithmic scale of Clostridia CFU per gram of fecal samples from the cow fecal samples. You'll see 10, 100, 1,000, so you're going up 10x with every line on this graph. You'll see the different regions, and then you'll see our limit of detection right here, this red dotted line. And what we found, similar to the database results, is 94% of the cow fecal samples had detectable levels of Clostridia. Typically, we see more challenges associated with Clostridia populations at over 1,000 CFU per gram. Less challenges in the 100 to 1,000 CFU per gram, and then when we get below 100 CFU per gram, less challenges are observed on that dairy. So you can see a wide range throughout the region, some very, very high, some very, very low, but very prevalent, 94% in that moderate to higher risk range throughout the region. 75% of the samples fell within this moderate to high range of Clostridia. So there's a different way to look at it. Breaking it down by region, you can see the average level of Clostridia in each region sampled. Now we did the same thing with Clostridium perfringens. Less abundant, but still over half the cow fecal samples had detectable levels of Clostridium perfringens, the toxin-producing Clostridium. So you can see very high levels, and if you remember that panel chart that I showed earlier, typically when we get HBS intestinal tissues from cows that died of Clostridium perfringens or HBS challenges, these are the levels we usually see, 100,000 to 1 million. So extreme challenge. Some other samples here within the high risk, some in the moderate, and then you can see the low. Comparing to calves, so 65% of the calves had detectable levels of Clostridium perfringens, varying highly between samples. And what we found in previous samplings, this is highly correlated to age. So younger calves typically have higher levels of Clostridium perfringens, a more naive immune system. And as they age, we naturally see this go down, but still present and a challenge within these operations. Then the feed samples. So this is looking at a different way. So this is percent of feed samples by each region. Here we have low levels of Clostridia within the feed, under 100 to 1,000 in the yellow, and then very high levels of Clostridia was in the feed samples in the red, over 1,000 CFU per gram by region. So you can see definitely a decent amount of samples within that moderate and high level, but mainly low levels. And we often get the question, 100 CFU per gram of Clostridia in the feed, that doesn't really seem like a big number. But when you do the calculation of daily challenge, the amount of bacteria that that cow is consuming in an individual day, and we use this equation, if you take the CFU per gram times the intake level times the conversion to grams to kilograms, you get the total CFU. So 100 CFU per gram, assuming 25 kilograms of intake times 1,000 is 2.5 million CFU of Clostridia that that cow is consuming on a daily basis. So I mentioned we also did the molecular analysis. So we did find, similar to the other dairies that we've sampled across the globe, our Clostridium perfringens was the most abundant, followed by Clostridium bifragmentis, the solvent producer disrupting rumen function, followed by Clostridium barranquia, another known solvent producer. We're most abundant in both fecal and feed samples. So from the genetic fingerprints, we typically illustrate this in a tree diagram, but this was way too big to fit on this individual slide. So instead, we represent those DNA fingerprints as individual dots. The closer the dots are, the more similar they are. The further apart they are, the less similar they are. So you can see they're color-coded by region, and we don't see any individual pockets of dots that are one color. So this indicates to us that Costa Rica shares diversity of these pathogens throughout the country, which let us know that we could customize this solution as one combination of strains covering Costa Rica. So to highlight the survey summary, Clostridium is prevalent in Costa Rica. 94% of cow fecal samples had detectable levels of Clostridia. Again, we're more concerned about the level than if it's there or not. 54% of cow fecal samples had detectable Clostridium perfringens and 65% of calves. 74% of the cow fecal samples had a moderate to high level of Clostridia. And we identified similar dominant Clostridium species as other regions, Clostridium perfringens, Clostridium barranquiae, and Clostridium bifragmentans. In 6 different regions that were analyzed, the diversity was very similar, so we could customize throughout the country. So we talk about this concept of strains are different, right? So we want to now ask the question, which probiotic strains are going to be most effective for Costa Rica? So these are all the Clostridium perfringens isolates. These are our best bacillus at inhibiting Clostridium at the top. You see 7 strains up here. And each one of these ticks is a different Clostridium perfringens isolate. This indicator right here is 100% is blue. Gray is about 50%, and red was uninhibited. So you can see all the good antimicrobial producing strains inhibited Clostridium perfringens fairly well throughout the region. So then looking at Clostridium bifragmentans, we can see that 2 strains really stood out to us right here as this first strain, very effective, where we get some misses here in the middle. And this strain at the end, very effective in inhibiting the Clostridium barranquia that was isolated from Costa Rica. And then if we looked at the Clostridium barranquia, we would see 1 strain very effective at inhibiting those target Clostridium within the region. So from this, we could identify what the most effective strains were to put together to inhibit the pathogens from a pathogen inhibition standpoint. But we also want to make sure that we're strengthening the gut. So other strains do that job, and we want to make sure we're including those strains too. So this is a lab test where these are simulated gut cells, and we can measure the electrical resistance that's flowing through those gut cells. We can add different pathogens, different probiotics, and determine, is it loosening the gut cells or is it tightening the gut cells? So we want our probiotics to be tightening the gut cells to make them more resistant from pathogens within the gut-borne system. So if we blow this out, this is the epithelial cells and different tight junction proteins holding those cells together. So this is some work that we've done. So we know the best strains at improving that gut integrity. So including those into the formulation, and we know the strains that don't. So we'll make sure those aren't included. Another way we can analyze this, so these are again, epithelial cells within the lab, that there's no challenge present, and we can stain them with for the tight junction protein occludin, cytoskeleton, actin, and then an overlay. So this is what you want to see, nice tight gut cells, all this yellowing right here. If we had a challenge, you can see a bunch of black holes within all these overlays, indicating that it's breaking down those gut cells, leading to cases like leaky gut. Now, if we add the bacillus to that challenged environment, you can see a darkening of the redness, indicating an increase in the tight junction protein, a darkening within the cytoskeleton, and more yellowing within that overlay. Another way for us to screen and see how we're impacting that gut integrity during challenge stress events. So using this information through the pathogen emission, through the improving gut integrity, we identify a combination of strains that is specific to Costa Rica for Certillus Costa Rica. So we've taken this approach in other regions and just wanted to quickly share a few of our trial results and so you guys can understand the benefits that you'll gain by utilizing this technology. So when we started this initially, this was a Wisconsin dairy herd. We were targeting HPS herds, so cows dying, right? So this was the pre-treatment period before they were feeding their customized Certillus. The first 90 days, they had 5 HPS death loss. They went on Certillus for 144 days and only saw 1 death loss. Then they asked the question, well, is it really the probiotic or is it something else that's occurring? Is something changing my feed? So they removed the Certillus for 97 days. And they had 6 HPS deaths lost. So they put the Certillus back in for 144 days, and they didn't see any HPS death loss. So we have a lot of examples like this, preventing death from Clostridia challenges. But as dairy producers kept feeding Certillus, they were reporting that they were seeing an increase in energy-corrected milk response. So we wanted to understand this, so we started a trial in New York, randomized controlled pen trial, 150 days, August through December. There was 2,300 cows split into 2 groups, control versus Certillus fed. And this herd was not experiencing any death loss, digestive losses, but did have subclinical levels of Clostridium perfringens. Remember that energy is being diverted towards fighting those pathogenic challenges and reducing production. So we saw first 30 days, this is cumulative milk yield, Certillus minus control. We saw an increase, but it was not significant. After 60 days, we saw a significant increase in energy-corrected milk yield that lasted the remainder of the trial. So then that's another thing to take note of. It's a probiotic. It's not a drug. So typically we say 90 to 120 days before you realize the full benefits of that probiotic and shift the microbial population to gain these benefits. Because you can see some response here after 30 days, but you don't see a significant until 60 days. So in this trial, we saw a 1.5 kg increase of energy-corrected milk feeding Certillus. So after this, we actually took fecal samples during this trial at 5, 10, 15, 18 weeks, Certillus minus control, log 10 CFU counts. And you see both total Clostridia and Clostridium perfringens were higher at the start of the trial. As the trial progressed, we saw that level decrease, and by the end of the trial, the total Clostridia and Clostridium perfringens levels were actually lower in the Certillus fed versus the control. We also took blood samples at those same time points, and we see a similar trend to what we saw for Clostridia, Clostridium perfringens. We measured haptoglobin and LPS binding protein as stress markers, and we saw them starting higher at the start of the trial. That reduced 10, 15, and were much lower than the controls at week 18. So next, we knew that we'd have an impact during that subclinical challenge level of Clostridia. So we found a herd in the western U.S. that had very low to moderate levels of Clostridia. And we saw a similar impact. We saw an increase of energy-corrected milk in the Certillus-fed cows over this 22-week period, a 1.1 kg energy-corrected milk response. And to highlight here, we also saw an improvement in feed efficiency. So we wanted to better understand this feed efficiency impact that we're seeing. So we enrolled a trial at Oklahoma State University, 28 lactated Holsteins, control versus Certillus fed. They're housed together but fed individually. And what we found was that we saw the same energy-corrected milk response due to the increase in butterfat. From an efficiency standpoint, we saw a significant improvement in efficiency. So we wanted to better understand that. Knowing that was the outcome of the California trial, we collected rumen fluid samples from these cows at a 13 and endpoint period throughout the trial. We did complete microbiome analysis, and we can see the treated group has a more uniform microbiome of all bacteria compared to the control. And knowing that we saw the benefit of feed efficiency improvement, we wanted to focus on the fiber degrading populations within these rumen fluid sample. So we worked closely with the University of Wisconsin-Madison. Tony Newman was doing his PhD work there, identifying fiber degrading bacterial populations. He identified the major groups in cattle as being Fibrobacter sexagenes 1, 2, and 4. This in combination with Ruminococcus albus, Ruminococcus flavifaciens, known fiber degrading bacteria within the rumen, we made qPCR's assay to quantify the level of these bacteria within that OSU sample. And what we saw is we saw a significant increase in the amount of fiber degrading bacteria within the rumen at both 13 and 25 weeks of the trial for Ruminococcus albus and Fibrobacter sexagenes type 1. So we wanted to repeat this, so we ran field trials of control treated and saw this same impact. So this was after feeding Certillus 120 days. You saw a significant increase in the Certillus-fed cows of the Fibrobacter type 1, 2, and 4 populations, increase in the Ruminococcus, but not significant. And then we did it at a second farm, but tried an earlier time point. So 60 days, 140 days. And at 60 days, we didn't see a significant change within those populations. And again, to reinforce, probiotics take time, typically 90 to 120 days to reach full benefit. We didn't see it right away, but then we saw the same results that we saw at the other trials. We're seeing an increase of the fiber degraders after 140 days in this case. So knowing that we saw an increase of efficiency and an increase in fiber degrader populations, we wanted to see if we're having any impact on digestibility indirectly by increasing those bacteria within the rumen. So we held a trial at the University of Illinois, 10 control cows, 10 Certillus-fed cows, 21 days prior to and 7 days post-calving. On days 63, 66, through 66, TMR refusals and fecal samples were collected to determine TMR afferent digestibility. And here we saw a trend in increased digestibility of organic matter, a trend of NDF digestibility, and a significant increase in starch digestibility within that trial. So, in summary from that trial work, we saw that Certillus can reduce digestive death loss through pathogen inhibition and supporting gut integrity. We saw it could increase performance, not directly, but by reducing subclinical pathogen levels and aiding in host immune response, and by supporting the rumen microbiome. From the free trial average, we saw an average of 1.5 kgs per head per day energy-corrected milk response. So, in summary for the presentation, we kind of highlighted that not all probiotic strains have the same function, and by taking a more targeted approach, you'll get a more effective product. We used the example of bacillus. Research supported microbial solutions to improve resilience, optimize performance by targeting pathogens, improving gut integrity, and improving the rumen microbiome. And now Certillus Costa Rica, his formulation has been identified and now available for use in Costa Rica. So I thank everybody for the time and the attention, and I'd love to take any questions if you have them.
Thank you very much, Jesse. Muchas gracias, Jesse. No sé si alguno tiene alguna pregunta para él.
Listo. Ok, gracias, doctor Jesse. Muy interesante. Yo tengo tres preguntas. Una, la interacción que hay entre el control de bacterias Clostridium en intestino y el incremento de bacterias benéficas para degradar la grasa, la fibra en el rumen. Eso es debido a una mejor colonización de bacterias degradadoras de fibra por un mejor equilibrio y un proceso metabólico que no entiendo. Esa es una. La otra.
Should I answer that one first? Yeah. Okay. So it's a really good question, and we've been chasing the answer to that question for about 3 or 4 years now, I'd say. So we have a theory that the solvent-producing Clostridium, the Clostridium bifurmentans, Clostridium baryonchii, are negatively impacting that rumen environment, which are having a negative impact on those fire-degrading populations. Now, we've taken rumen fluid samples. Rumen fluid samples are more difficult to get than the fecal samples and the feed samples, the typical samples. Typically, Clostridia are prevalent in the rumen at a fairly low level. We did do one additional study at the University of Illinois where we actually got rumen tissue where they were much higher. That might help us answer that question, but again, a very difficult sample to get, so we haven't necessarily been able to support or refute our theory on that. Yeah.
Ok, gracias. Luego, cuando se desarrollan las cepas que van a controlar los Clostridium, ese Clostridium SSP, y esos controladores es para todos los bands de Clostridium. Me explico. Clostridium D, que es el que produce la toxina Epsilon, que es una de las más importantes por su toxicidad, se vería también controlada, digámoslo así.
Yeah, so just to clarify, the question around different like Clostridium with fringes type A, type B, type C, type D, and how we can inhibit the different types of Clostridium, is that correct?
Sí, correcto.
Okay, yeah, so initially we did this work in the U.S. I think we collected I'd say around 10,000 Clostridium perfringens isolates from U.S. dairy fecal samples. 99% of those isolates, so we ran a Clostridium perfringens toxin, multiplex looking for alpha-beta epsilon iota toxins. 99% of those isolates coming from the fecal samples, not saying they're not other locations within the animal, were Clostridium perfringens type A. So now to streamline our process and quicker identify these different populations, we only screen for Clostridium perfringens alpha toxin. If you're seeing a higher prevalence of Clostridium perfringens type C's or D's, we have the DNA for the isolates. We could go back and look at the multiplex. But again, to answer your question, we've done screening on the limited number of type C's and D Clostridium perfringens that we've collected and see just as effective results.
Y finalmente, el desafío que tenemos con micotoxinas es alto. Principalmente sabemos que fumonicina y DON afectan la integridad intestinal, que favorece el desarrollo de bacterias patogénicas y en general bacterias normales de la microflora. Al tener nosotros un mejor control, podemos minimizar ese efecto endotóxico causado por bacterias cuando tenemos presencia de micotoxinas.
So again, to clarify, is your question, are we getting a more impact from mycotoxins with the presence of a high level of pathogens, and if this solution would be aiding in that challenge? Yeah, so obviously if we want to limit the amount of challenges occurring, we're inhibiting the pathogenic population within the gastrointestinal tract. We're not having a direct impact on the mycotoxin, but we're strengthening those epithelial cells, tight junction proteins, to make that gut more resilient to those types of challenges. So again, on dairies, you'll typically see a number of stack challenges, right? A number of stack stressors. So the more stressors that you can remove, the less of an immune response you're going to get on that.
Muchas gracias, Jesse.
Thank you very much. Appreciate it.
Charla.